So Carl, tell us briefly about Avassa and your role at the company.
Sure thing. So Avassa is a Swedish software company out of Stockholm, Sweden, founded about 3 years ago by a group of industry veterans that have spent quite a bit of time thinking and acting on how to solve for automation and orchestration, with a background actually in automation and orchestration for infrastructure. We realize that the focus or the focal point for many enterprises are slowly moving away from infrastructure and into the application domain. And notably, actually, we found there to be a very interesting challenges around not so much managing applications in the cloud or any centralized cloud, but actually managing applications outside of the cloud. So we kind of started obsessing over that 3.5 years ago, founded the company, realized that that's actually called the edge for many people. So it made sense for us to start a company focusing on managing applications in edge environments. So that's kind of the background. I am one of the founders. I have one of these very elusive titles. I'm the CTO, which in our case does not mean that I'm the best developer, but that I'm probably one of the more extrovert out of the founding team. So I spend most of my day doing extroverted things like talking to you, Jim.
Thanks for doing that. I appreciate that. I know it's not always easy for engineers to do that. So
I'm taking a big one for the team over time here. That's the way to think about
it. So many enterprises find it challenging to lifecycle manage applications across a widely distributed infrastructure. What is needed to efficiently operate applications at the edge and at scale?
Sure. So the interesting, but at the same time terrifying thing of starting a new company is that you literally, in most cases, you have pretty much a blank slate when it comes to the exact details of how to design and, of course, create, in this case, a software solution to a problem that you think you understand. The good thing about it is that going in, if you have some experience, you know that you understand about half of it, and then the rest you are going to experience yourself as you build this system. So we've built one, and we're in kind of interestingly wide deployment. So I think there's a couple of things that we have managed to learn along the way. And I think there are two things that really stand out, or actually there's one top level thing here that we've really learned the hard way, is that the edge, the way we describe it, by the way, which can be kind of probably whittled down to saying few computers, but in very many locations and where the location matters. That's kind of our hard and fast definition of the edge. Actually drives a number of interesting requirements that makes it very different, subtle, but very different from the centralized cloud, because almost all of our users, of course, have some sort of experience from the centralized cloud and operating applications in the centralized cloud, and by the way, managing centralized infrastructure. So we usually start with talking about what's different. And there are two aspects of it that, in my mind, really sets it apart. The number one thing is, again, the profound impact of having location matter. Actually kind of permeates the entire idea of placing and managing computer programs. Because, of course, the whole placement and scheduling kind of explodes on you. You know, there's some deeper thinking that needs to be done roundabout trying to grasp the fact that not all applications are going to run in all locations at all times. That there is some sort of idea that you have to capture roundabout which of my applications should be running where, or maybe under which circumstances. And that is in stark contrast then to having like a single cluster, for example, that many people have in the cloud, or maybe two clusters where there's a disaster recovery, a second cluster for disaster recovery, where that kind of problem space is it's not a thing. It's not generally something you have to think about. Location is not a primary concern for you. So trying to grasp that, I think that's the number one thing that I always try to tease apart. Started to think about what does it take for you to gain control over where your applications are running and under which circumstances you want them to run. So that's the number one thing. And that impacts people that care deeply for applications, that want to place and schedule applications in the right locations at the right time. So towards the application team, the people in charge of releasing applications into production. The second thing is more of a day 2 or day 3 thing, and it's about monitoring and observability in the distributed environment. It's kind of the same thing, right? It's a big difference between monitoring and observing, let's say, 20 different containers or 20 applications in a single cluster. It's kind of intuitive, or at least a recently lived experience to understand or grasp what monitoring means and what a healthy application means. If you think about an application that has maybe a 200 or 1,000 replicas across as many locations, of course, trying to understand what healthy means in that capacity is just a different way of thinking about things. So understanding where the applications are and how they're doing is different when you do it across hundreds or thousands of locations. So maybe just to make it easy and simple to grasp, and usually as a conversation starter, I usually say, think about deployment and scheduling where location matters, and think about what it means to monitor and observe applications when they're running in thousands of locations and not one or two. So I think those two things should be at the heart of any solution like this, and at the heart of the thinking of anyone pursuing that kind of edge infrastructure.
So, excuse me. What approach then should engineers take when they are managing applications that have code in the central cloud, but also have some sort of client, whether it's an edge device or an edge server? They also have clients that are running components at the edge.
Yeah, I mean, every user we have been in contact with this far is clear about the fact that any application that they run at the edge have some sort of corresponding functionality or corresponding application in the centralized cloud, ranging from, you can think of a point of sales application for retail, of course, communicates with a centralized database with a centralized set of components for, let's say, loyalty programs and other things. And of course, every kind of AI or machine learning inference application that you run on industrial shop floors, of course, they do a lot of heavy lifting with the inference at the edge, but they always transact the result to a centralized environment. So there's a really interesting kind of emerging topology here, kind of an application topology that spans the edge and the centralized cloud. And as you have, for example, feature growth, you should think about both components as a coherent whole. And so that kind of going back to what I said on the previous question, it really impacts both how you deploy or orchestrate the releases of new features, because it usually impacts both the distributed components and the centralized components. And of course, if you want to have a deeper understanding about the health of your application, it is the combined behavior of your distributed components and the centralized components that actually matter. So taking that approach to understand how do we maintain control over both so that they can actually be released in the same pace, they can be monitored in the same pace, they can be observed across if needed. I think that's a really, really important step. Don't look at them as two separate domains with operational, or for that matter, organizational firewalls between them. Make sure that you give a single team or some sort of coherent team the operational responsibility, both for the life cycle of those applications and the health or the monitoring of those applications. So thinking of both sides as a coherent thing, I think, is at the heart of trying to really design something really well. So that kind of ties together edge native and cloud native. I don't even know what to call it, some sort of meta native or two-tier native or something. I don't think we have the taxonomy for it yet, but I think that should be or should become an interesting conversation for the industry kind of going forward when people realize this kind of emerging topology here.
And so how would that notion tie into the growing thought that we should approach things from a platform engineering perspective? Has there been enough consideration of how platform engineering works with edge?
I think the kind of fundamental idea between platform engineering is actually a perfect starting point for an internal conversation about this. I know everybody has an opinion, and there is some overlap, but not perfect overlap between people's perception of what platform engineering is. I've decided to focus on kind of a single assumption with platform engineering, just to make it easy on myself and for people that want to listen to me. And it is the fact that people, or what we used to call IT or platform teams now, that at the heart of what they do is to provide infrastructure that is easily consumed by people or for teams with application mindsets. So that is what I think is a very, very nice starting point here. How can platform teams organize themselves around more of a product thinking so that they can provide useful features and a useful environment for application teams, for people bearing computer programs to manage their computer programs? So that kind of ties back into actually both of the questions that you asked, with this nice teasing apart of the roles and responsibilities and the core challenges. I think thinking about the edge as just another substrate that should provide the same ergonomic feel that the cloud has managed to put together over the last couple of years, and the same thing to allow for a setup or a platform that actually allows application teams to host the components, constituent components where they matter the most, usually a combination of at the edge and centralized, in a way that's actually held together in some coherent form. And I think one of the more interesting emerging discussions then in platform engineering is the one about IDPs, or internal or integrated developer platforms, which at its heart is a way of providing a portal-like experience, both for onboarding, but also for features along the life cycle of applications, aimed at providing a comfortable environment for application teams. And I think that is actually the start of an architecture to provide that kind of two-layer or two-side topology management that I talked about. This might just be the orchestrator of orchestrators that we've been thinking about the last couple of years, that ties together the centralized components with the edge components. Now, these are still very early days. In my mind, the platform engineering discussion is just starting, and it's kind of focusing a lot on knowledge transfer and documentation and many other things. But I think it's the perfect jump-off point for conversation about how do we provide, again, a coherent experience for people that care deeply about applications, maybe a little less about infrastructure, that would allow them to put the components where they should be living, or where they should be hosted, usually a combination of the distributed edge and the centralized data center. So I think it's a very, very interesting direction that we should follow and contribute to the extent that we can.
And so, tying into some of these other issues of manageability, what role does observability play in the management of nonstop operations?
I think one of the more interesting learnings that we have from let's say the last year and a half, when we've been in production with users or with customers, is that one of the more profound expectations that we have from our end users is the survivability of applications in the face of, let's call it, upstream outages. Just the basic assumption that because you host applications inside of the retail store, inside of the hospital, or inside of the industrial plant, it should be allowed to survive, or that should provide the basis for survivability in the face of upstream outages. What's really interesting with that, though, is that it's a way of thinking about applications that, again, we never had to do with the private data center or the cloud. That's usually n-way redundant in all kinds of ways, and any outages is usually not because the network itself stopped working, maybe BGP or something like that, but not network outages in general. So what you really have to do in order to facilitate the nonstop operations is provide observability, both for, of course, operational teams, but also for the platform itself, if you like. So observability, again, the way I think about it is the ability to interpret, or maybe even ask the infrastructure and the application layer about what's going on. Not so much measuring the health, but actually go a little deeper and look at the current behavior of applications. And in order to do that, if you have a very distributed environment, of course, then you have to provide some sort of means of doing it in a very targeted fashion. And you also have to be able to allow the platform itself to use observability to take, let's say, decisions about how to keep an application alive. So, for example, even if you're a fully offline mode. Even if your, I don't know, your retail store is fully offline and your application crashes, the system needs enough observability or enough detailed understanding of the behavior of the application to be able to restart it, for example. Which is a very, very interesting challenge, and a really key part of what we believe is the promise of nonstop operations at the edge. So observability has kind of been a broad discussion or broad description of particular tools. I think in this case, observability is truly at the heart of the way we need to build nonstop operating edge clusters or edge sites, if you like.
So it just occurred to me that maybe, would it be fair to say then that nonstop operations doesn't necessarily mean nonstop in the sense of, say, the old mainframe days where something really is literally 99.999% uptime, right? It's assuming and knowing that something will fail and then getting it running again quickly. Is that an accurate description, or should we think of a different way of characterizing nonstop?
No, I think you're definitely onto something. What really happened, one of the things that Kubernetes actually brought to the forefront was what it's built upon is the commoditization of what used to be very complicated clustering mechanisms. For the people that care for it, of course, the commoditization of things like the Raft algorithm, which is at the heart of Kubernetes, is really key to, I think, understanding how we can provide nonstop operation on a cluster level. So the ability to, just like you said, react to, for example, applications failing by different strategies, try to restart that, and if it doesn't actually come up, try to actually reschedule on another node if we have the resources. So that kind of a little more clever survivability based on commoditized clustering functions or clustering features, I think, is at the heart here, and making sure that you have enough resources and that you have enough contextual information at the site to be able to do this, even if you're offline, even if you're fully disconnected from the internet, is a formidable and very interesting task.
And so now I want to throw in a bonus question, because there's only 5 million articles every day about what is ChatGPT and what is its impact on this X, Y, and Z. We've discussed in the industry low code and no code and the impact of that on development. Who is going to start developing? Gartner and others talk about citizen developers and the growing role that they will have in enterprise application development. I'm curious, what you've been thinking as you've seen people use generative AI to create, even people like me might be able to create fairly sophisticated applications. What does that mean for your application, your platform? What do you think its implications are in the industry, more broadly speaking?
There's literally a myriad of ways to take that question on, because I think it's the mother of all open-ended questions. But I love it. So I can offer you three quick ones. And one is that I will say that as an industry, and this goes back to actually many years now, we've struggled with making monitoring data actionable. And I'll just throw this in. There's nothing new about this, but making monitoring data actionable kind of assumes that you have an enough volume of data that can be identified and kind of mapped towards particular actions. I think, honestly, with the data center kind of small blast radius environments that we've been talking about up until now, we haven't had enough training data to actually do something useful about it. I think that having, again, applications running in thousands of locations will provide enough data that we can quite rapidly become, and I'm going to use a term that I try to stay away from, but self-driving, or where we do manually assisted operational interventions based on identifying clusters of activities. So that's one thing, and that's probably just an extension of what we've been talking about for infrastructure for a long while. The second part is kind of maybe more interesting. It is assuming that a system like ours, system like the Avassa system, that fundamentally manages applications running across a scalable edge infrastructure, There are declarative data models or declarative data at the heart of any system like this, where you describe what does an application look like and where or under which circumstances should this application run. It is, of course, trivial to think about having that actually defined through more of a natural language exchange with the system, and actually drive the actual behavior of the applications and the placement of the applications and the resources assumed by the application through natural language processing. To be honest, I'm not that could probably improve developer experience or operational experience. I don't think it fundamentally changes the game. I think it's icing on the cake. What is more profound and kind of ties back into what you're saying is that right now, as an industry, we're focusing on containers. We're moving away from VMs towards containers as the atom of deployment. What is it that the more head spinning thing is when you start thinking about, is that in GPT land or in large language model generative coding environment, is that truly the atom of deployment? Probably not. Maybe at the bottom layer, but I think above that you are probably looking at something more like a serverless deployment unit, and you're also probably looking at more of a data stream unit than the containers themselves. They are a little raw, so to speak, even though of course they can play well together. So I think for the really forward-looking aspects of it, think about what the atom of deployment or atom of management is in a world where you have like you said, a generative citizen developer style environment, and how maybe a citizen could explain to the system, this is the kind of application that I need, and here are the expectations on where it's running, and how that deliverable could look like for a system like ours. That's more of a forward-looking idea, more of a forward-looking kind of exploratory arc that we're on, and that would make a big difference. And you can then think of course, right now we see a pretty strong one-to-one relationship between who owns the edge and who runs applications, right? And it's usually the same organization. The retailers own their own edge, they run their own applications on them. Here you could think of a multi-tenant edge where you would allow, again, I'm going to cling on to that citizen developer, where you would have tenants that are citizen developers that would then describe in natural language maybe to the system what kind of application and where to run it on top of other people's infrastructure. I think is also a very interesting angle to this whole thing. But on the other hand, I keep going back to the fact that just because I think I understand the technology, it is super, super hard to understand how this is going to land in this very interesting landscape that we're in here. So these are like three humble angles to what could happen here, or what could be interesting to look forward to.
Well, far be it from any of the analysts to hesitate to predict those things. That's kind of our job, and it's a guessing game.
It is
a sophisticated one, but I appreciate your input on that because, I guess after listening to your answer, it's still important at the end of the day to have the data, to observe that data, and to be able to orchestrate the application, no matter which way it was created or who created it.